Hello, everyone. Welcome to our second workshop in our three-workshop series on voice-driven agentic AI, part of the Pub Health AI Collaborative Network workshops. We are pleased to welcome Christopher Collins from Austin Public Health to present on voice prompting to build a simple SaaS tool with a web agent and show the importance of using GitHub and version control. I know the Claude API is down today, so there might be a bit of an adaptation of the workshop, and we might have a follow-up on this, but I will give it to Chris to take it away.
All right. Hey, everybody. I'm Chris, if you remember me from the last workshop. Today, we're going to do a little demonstration and workshop working with Claude Code to create a simple software as a service offering that you might provide to your constituents. We're going to walk through a little bit about Git and version control. We're going to talk about some customizations inside of Claude Code. I'll show you a little bit about doing version control, but mostly we're going to focus on how to build stuff using your voice and prompting directly within Claude Code. We are having some issues with the API today. There've been some outages happening, so we might have to make some pivots. So just hang with me and we'll try to work through some of the technical glitches. And if we can't do everything 100% live, I'll show you some backup stuff that we have. Before I get started, though, does anybody have any questions either from the last session or is everyone familiar at least with Claude Code or have any questions about Claude Code before we get started? All right, cool. Well, first I'll show you an example of what we're probably going to be building today. So this is a small app that I call the Policy Plain Language Converter. And what it does is it uses GPT-4 Mini under the hood because it's faster for this demonstration purposes. And it allows you to copy and paste a complex policy document and you click a button to convert it. And then it sends the policy out to the AI. And what comes back is 3 different plain language versions of that policy document. One of them is an executive summary. One of them is a really cool staff briefing. So like what you might send out to your staff. And then another one is like a publicly more accessible version of that thing that basically boils it down into the key points and writes it in a language that they can understand.
Hey, Chris, you're not sharing your screen right now. I don't know if you are.
The screen's not sharing?
No, not at the moment.
It says I am.
I'm seeing.
Oh, you can see it. Okay, this is on me then. Go for it.
Okay, cool. All right. And so I put a link in the chat. And what that link is to is it's to the GitHub repository for the files that we're using here. And the demo app I've provided to you, if you follow the instructions in the README, you can basically just put your information into the configuration files, and then you can install the app and launch it. And then it will be customized for either your public health agency or your department, and it should work for you. The key things that you have to have is you have to have an Azure AI endpoint or an OpenAI endpoint for the AI. But other than that, everything will work for you. Some of the tools that I like to use are VS Code. It's free. It's downloadable on the internet. You don't have to have anything super special with it. And this particular project will work whether you have VS Code or not. You can just use a text editor or your favorite tool set as well. I've also tested this out with both Claude Code and Codex and some other coding tools. And the prompting methodology we're going to go through today works across all of them. One of the reasons that I like to use Claude Code is I think it provides a little higher fidelity in the end product. And so with that, I think there is one question in the chat. Let me see what that's. Okay, I think they reposted the link. And would you like a link to the content from the first session? I'll put that in real quick.
Yes, please. That'll be helpful. I haven't seen the first session. This is Kanaya.
It is coming in. So I guess I'll do just a real quick recap of the first one so that those of you who missed it kind of know what's going on. So the general premise around what we're doing is we're controlling our coding applications or our AI applications with voice. So we went over how to use an app called SuperWhisper. It's the app that I like to use for all of my voice control. I'll show it to you here on the screen. SuperWhisper has a couple of cool things that it does that are different from some of the other voice control apps. It has models that will let you process your voice 100% locally on your computer so that you don't have to send it out to an AI. It allows you to create custom modes where you can use different blends of AI services to process your voice prompts that you give it. It allows you to pull in context from other applications and kind of stack things together to get really meta with your prompting and increase the power of voice input. It has some pretty advanced vocabulary capabilities, so you can create macros and triggers. And it's got a lot of different models that you don't have to have locally on your computer. If you want to use high-powered foundation models, they have a little menu of all kinds of different models that you can just plug in and use without having to set up a complex subscription. So it's kind of cool. So this is going to be kind of the heart of what we're using today when we do the voice prompting, which I hope my voice holds out for. And so the first session is all about how to set that up, how to configure it and customize it. And today what we'll talk about is the methodology behind putting together prompting in a way that you can build an app with these AI agents in a repeatable, durable process. So the primary objectives for today, and like we said earlier, these timelines are going to change because the AI is having some trouble. So we're going to have to be flexible on how we do the demo. But the general idea is to show you how we'll use the coding tool as a project team. It's going to help us generate the idea, develop our user stories, write our entire requirements documentation set, and build our prompts. And then in one shot at the end, we're going to have it build the whole app. So it's really important to start off by understanding what an AI harness is. So Claude Code and all these other tools you've heard about like Cursor and Windsurf or Copilot, they're just what's called a harness. So think of a harness as like the car. So a model is the engine. So Claude or ChatGPT are the engine, but the harness is everything else that's around it that turns it into something that you can use. The harness typically is comprised of 5 different components or processes. There's prompting, and then there's some sort of a planning engine built into the harness where it can create and track a list of to-dos, or it has a specific mode that it can enter and do a planning step. They can also execute commands and run code. So some of these harnesses create virtual environments in the back end behind them, where they can run commands and edit files that are either locally on your computer, or they can do all their work in the cloud. The harness also provides the AI a way to observe what's happening with the project. So it can read the output of commands. These new versions can do things like open a web browser and open the app and click on the app, and they can see the screen and they can interact with those elements and observe their input and output. And then the most important concept is that they can iterate. So they can execute the command, they can observe the output, and then they can modify their behavior based on how things are behaving. And that's the simple part that really gives them their power, is that they can see the output of the command, and they can then either fix a bug or they can modify the code to get a different output. And the harness just allows that to happen over and over again in a loop. And so in 2025, everyone was talking about agents and agent activity, but 2026 is all about these harnesses. And you're going to hear about that more and more as the year goes on. And I don't know if some of you keep up with like AI and AI news, but like Andrew Karpathy the other day, he was one of the founders of OpenAI and helped create ChatGPT. And he had a tweet that came out and he said, 2026 is really like in the last 2 months has been this huge decisive leap in coding capability. Just 2 months ago, we were kind of struggling with creating code and you had to put a lot of work in to get it to behave and do the things you want. But here in the last 2 months, there's been massive leaps with these new models and how they behave and can iterate. So what makes all these different coding engines or harnesses different? Well, they all have different methodologies, but they do the same core stuff underneath. They all do those 5 steps that we talked about. But you'll have like Claude Code, which is primarily based in the terminal. So that means it really just kind of works off of the command line. And everything that you do takes place inside of that terminal environment. So there's not a big fancy user interface around it. They do have a version that can work on a Mac computer if you have a Mac that has a GUI. But really, Claude Code has made a statement that they don't want to get in the game of trying to keep up with advancements and changes in the interface and the UI. And they don't want to become a new what's called an IDE, like VS Code, because it burns a lot of resources and they feel like they get lost in trying to play that game of keeping up. And then they'll lose sight of being able to do what they do best, which is just write code. Then you have the opposite of that, which is Cursor. So Cursor, as a company, decided for their harness, they wanted to use the entire IDE. So they started coding directly inside of what's called a fork of VS Code. So they took this whole coding IDE and then started embedding AI all throughout that interface. There are some other agents like Factory Droid and GitHub Copilot that are attempting to operate across both spaces. So they have both command lines and they're available inside your IDE. Gemini Anti-Gravity is following the same path as Cursor. In fact, they bought a company called Windsurf, or a tool called Windsurf, and that's what has now become Anti-Gravity. It's very similar to Cursor, but the biggest change between all of these is just the model that's under the hood. So one of the things that makes Claude Code different are all of the tools and features that are under the hood. So Claude Code is comprised of a couple of different major components. We're not going to deep dive these today. I just kind of want to make you aware of them because you're going to see some of this stuff potentially triggering in the background. So skills are specific sets of instructions that the agent can pull into its context that can dramatically change its behavior. For example, there's a skill for front-end web design. It's a whole package of information about how to do great user interface design and design great user experiences, and it comes with different templates and patterns that it can copy or use as inspiration. So if you're working on trying to design a really pretty front end for a website, you might see that Claude Code by default kind of tends to produce the same look and feel. But if you just run a / command and you type front end, it'll trigger that skill. It'll load up all the context. And then all of a sudden, Claude is now outputting state-of-the-art, really amazing looking websites. And so skills can also be something that you can create whenever you want. And you can create skills to do anything you want. You could have one for database work. You could have one to create reports and designs for your data team. You could have another one that focuses on writing really great, engaging content or stories. So skills are one of the things that really make Claude Code super powerful. Another thing that is in Claude Code that's really important is called hooks. So hooks are scripts and a lifecycle command that automatically triggers when Claude Code does a certain action. So for example, if Claude is about to edit a file, a hook can fire before or after the file edit is made and inject specific instructions into the prompt, or it can actually run a command on your computer locally. So we can do things like block dangerous commands from happening. That's how you keep Claude from deleting files off your computer. Or you could have it run what's called a linting check. So after you write a large piece of code, it can run a linting check and see if there's any errors or problems in the code. Slash commands are kind of like skills, but they're much shorter. Think of them almost like prompts. So you can create a specific prompt, you can give it a slash command, and then whenever you type that slash command, it essentially just runs the prompt for you. I have different slash commands set up for my planning and my writing processes that just make it easier for these repetitive tasks that you do over and over. You've probably already heard of MCP servers. Those were the really hot thing last year. So MCP servers extend the capabilities of Claude, let it plug into different tools, access databases, and browsers. Claude also has some of the best what's called sub-agents. So sub-agents are basically little mini versions of itself that it can spawn, create a task list, and then it can have like 3 or 4 child agents do work in parallel. And it just speeds up the process of working with Claude. There's also the Claude MD. The Claude Markdown file is a file that Claude makes automatically for you if you run the init command, or you can create one for yourself. And it provides persistent instructions and rules and constraints around how you want Claude to act within your project. And then finally, the last two, compaction and YOLO mode. So compaction enables Claude to work for a very long time. It can do a big long list of tasks and then reach what's called its context limit when its memory is full. It can recognize that, and then it can summarize the conversation up to that point, which frees up like 80% of its context, and it can continue working. This is one of the key things that enables it to do what's called long horizon task work. And then there's YOLO mode. So YOLO mode is turning off all of the safety features inside of the tool and allowing it to automatically accept every action. So it will stop asking you for permission to do things, and it will just do them all on its own. And we're not going to use that today, and I highly advise against it unless you're working on a project or computer that you don't care a lot about. So what we did instead of running in YOLO mode, and you'll see on the internet that people want to use YOLO mode because it allows Claude to work for very long periods of time without human interaction. But you'll also see those same people come back a couple of days later and complain that it deleted all the email in their entire email box, or it deleted their whole database or their computer. So my solution to that was I set up what's called the permission hook. So I use that feature that I talked to you about called a hook. And every time Claude has a decision point, my hook fires and it forwards that decision to a small language model, a mini model. That mini model has a prompt, specifically looks at the command that Claude is trying to run, and it determines whether or not it is safe. And then it allows a lot more adaptation than the strict regex blockers do. So what that means is a lot of blockers will block very specific commands, but there are times where you might want to remove a folder or a directory from your project. And it may be integral to keeping the task moving along. But with the strict blocking, this built-in component would just stop that. And then you would have to come back and interact with the system. So the permissions hook lets another language model be your supervisor for you and make those decisions. So the little mini large language model will read what Claude's trying to do and then decide whether that's safe or whether it's destructive. And what that has enabled is we can fire off this project that I'll show you in a minute, and it will run potentially for hours without needing to be attended. Some other things that you can do are like customizing inside of Claude Code are custom memory servers, so that Claude can remember what it's done from session to session, or a little more fidelity than when it does those compaction events. It can also kind of learn patterns and processes within your project over time. They now have built in a memory server. So the latest version of Claude, I think it just came out yesterday, now has a memory server by default. So you don't even need to use these add-ons. We'll have the LLM permission hook that I just told you about is active. I do have some planning and slash commands, and we'll dive deeper into those in the next session. And we're using the SuperWhisper voice input. So let's talk a little bit about setting up your environment to get ready to do a project like this. So this will work across any of the modern OSs, Mac OS, Windows, or Linux. Windows does have some hurdles, but if you've already got Claude Code working on your computer in Windows, then you've probably done the majority of the things you need to do to be able to work this project. Claude Code and a lot of coding tools now require Node.js. This project requires Node.js 18 or greater. Git, which is our version control system. It's very important to managing projects with code. Is there anybody that's not familiar with the Git system, or would like me to talk a little more about it? Everybody good? All right. So one of the main things that we use Git for is if the AI does make a mistake, we can back out of it and roll back to a known good state to continue to move forward, because AI does make mistakes. You'll need Claude Code. You can do this project with any of the other systems. I've tested it, like I said, with Codex. It does work. But Claude Code, I think, gives a little bit better end product. You'll need either an Azure OpenAI API key or a OpenAI API key, and configure that in your environment variable file, and some form of a text editor. Inside your .env file, does everybody know what an env file is?
No.
Okay. A .env file is your environment variables. When you're doing these web projects, this is where you basically put like your secrets or your configuration information. That file gets excluded from being uploaded or distributed with your project. So it's a way that you can safely provide sensitive information to different tools and processes within your project without exposing them to the world. And so in our .env file, we're going to give it our endpoint, which is the URL to our API. We're going to give it the key to access the API endpoint. And then because we're on Azure, we're going to give it the deployment name, which when you set up an API endpoint in Azure, you have to give it two things that are different from a standard endpoint, which is you have to give it a deployment name and an API version number. And these things get appended into the URL and into all the API calls. So every time you try to process something with the AI, it has to send all of this information to the server in order for it to authenticate and work correctly. And so I provided an example file in the demo. And all you have to do is plug in your information and then save the file, and then make sure you rename it to where it's just .env, and then your project will run. The other thing that we need to do when we set this project up is that we need to set up our project folder. If you want it to be able to adapt to your brand and your style guide, which is something that I almost always do as a best practice, I took my, yeah, you have a question? Go ahead.
Yeah, what does it take to set up the Azure OpenAI API key?
So you need to have, first of all, access or a subscription in Azure.
Okay.
And then you'll go into what's called the Azure AI Foundry.
Uh-huh.
And then there's an area in there for deploying a model. So you'll deploy an OpenAI model from the Foundry,
Okay.
and then it will give you the URL to that. And if y'all need to see like how that happens, we could do that in the next session, and I can walk through like how you actually set up that model and deploy it. But you could also use this project could be used with regular OpenAI. You could even use like Open Router if you want to. If you just wanted to like charge $5 worth of credits, and use any model that you want if you use Open Router.
Oh, okay. That's what I was thinking, open router, you can choose the model, whatever the model that you wanted. So in that way, you set it up once and then you can use it for any model that you want to do, is what I was thinking. Thanks for
Yeah. So you could totally do that for this project, and you could just change your prompting around and say like, hey, instead of researching Azure, I want you to research OpenAI, and we'll go through that.
Okay, thank you.
All right, and we talked a bit about Git, right? So, Git is your rewind. It's the thing that's going to keep everything safe. I'm going to give you guys this deck. It's already uploaded to the repo, so you can go through it. But there's some key commands that you really want to make sure you understand what they do. Thankfully, the AI are extremely good with Git and Git commands, so you don't have to necessarily tell the AI to do all these things. You can just tell it to use Git and make sure you're committing often and securely. But basically, when you create your repo, one of the first things you have to do is you have to actually initialize Git. There are specific commands for adding the changes. A commit is basically a save point or a checkpoint. Git has a very complex log and logging history, so you can go back and see the history of all the changes. A Git diff is showing you exactly within any file what was changed within the file. So the cool thing about Git is not that it just like goes back to a previous copy of a file, but that you can literally go through and see the specific edits that were made within a file in case you only need to back out small changes. And then there's a way to basically rewind and create branches. And that's done through this checkout command. And you don't need to learn all this stuff today. It's just something that you need to be aware of because this is your CYA as you're moving forward with these projects. If you have a hiccup, you'll be able to back out. All right, let's get started because I think the API might be coming back online. All right, so what I'm going to show you today is kind of a slimmed down version of the full workflow we'll do in session 3. Basically like how you can get from an idea or a concept to a MVP within about 20 or 30 minutes, depending on how fast the AI decides to run. It's a practice that you can replicate. You can do this with any idea or concept you have for an app. It could be a dashboard. It could be, whatever. Sky's the limit. It's learning how to use the AI as your whole development team and help you do a lot of things that maybe you don't practice every day. And this will be a reusable methodology. It's yours to copy, change, do whatever you want with it. So within the 10-phase life cycle that we talked about in the last session, we're going to cover the majority of them. We're going to cover GitHub repo. We're going to do the brainstorming, the deep research, the planning, the prototype, the documentation, the PRD, and the agentic execution. All right, y'all ready to see it? Do some action. And I apologize for the lawn mowing in the background if y'all hear that. So setting up the project. This is the folder that we're going to be working in. So I've got my environment variable file that's already pre-populated with that information that we talked about. I have my style guide. So my style guide, the reason that I give them these is just so that my end product looks like what our department has decided are their brand guidelines. So I took their big long PDF and I converted it into a markdown file. And I had AI do this for me. So I just gave the AI this 30-page branding guidelines document, right, with logos and all the information about the colors and the typography. And I had it make a condensed version and put it in what's called markdown format, which is just a formatted text document. So now I can load this in as context when I start talking with the AI. And when it makes my design, it'll already look like something that came out of our department, and it will have everything in the official colors and styles. So the context chain that we're going to create today and all the steps we're going to go through is first, we're going to tell it about our idea, and it's going to go do some research on the key technology behind it. Then we're going to have it brainstorm with us to kind of brainstorm what features and functions it needs. We're going to have the AI do all the hard work around the user stories. So it's going to create user stories. Does everybody know what user stories are and what sprint planning is, or does anybody not know? All right, cool. So we're going to have it do all that work that like an agile team, if you've heard of like agile development, it's going to basically do all that work for us and simulate the users for us. And then it's going to design the PRD, the requirements document, and then it's going to chop up the requirements document into all the sprints. And then we're going to create an orchestrator file, which is really the engine for everything. And the orchestrator file is what Claude is going to use to go execute the content of all those other documents and build the whole thing for us in one shot. See if I can make this a little bigger for you. All right. So we are going to start off by kind of setting the stage. And we're going to tell Claude who we want him to be and kind of what's going on with our project. And I'm just going to do this through a voice command and talking with him. So hopefully the voice command will work while we have the meeting running. We'll try it out here. Hey, Claude, you're a senior AI developer working on a city government project. I want you to inventory the current directory, including all the files and the style guide folder. Next, I want you to research the Azure OpenAI REST API format for Node.js. You should also research professional PDF formatting libraries that can output Gartner-level executive summaries. I want you to write your findings to a file called research.md with 3 sections: an environment inventory, the Azure API implementation, and the PDF formatting strategy. All right. Ooh, let me pull this over here. Hopefully he's not down. We're going to try one more time. Okay, he's back. All right, so Claude is taking our prompt. And because Claude Code can run lots of different commands and has access to many different tools, it can go out on the internet and do all the same things that like you've seen ChatGPT and Claude Online do. So you'll see what it's doing right now is it's looking inside and inventorying the project directory. It's going to pick up our files and folders, our .env file. It's currently researching the OpenAI REST API. So it's the reason that we do this is to make sure that it has current information and context. You could tell Claude to just build you this policy application using the OpenAI API, but more often than not, it will default to whatever its training data is. And the training data could be old. And sometimes the specific data about any API that it might be using could be really old. And so when it finishes building the application, key parts of it may not work at all because it's not using current information. So this research phase that we're doing is something that like a project team that was going to sit down and build this application would typically have to go and do. They would have to research these libraries and packages, how to make these API calls with the recent and up-to-date methods. And so we're having Claude create these agents and do it all for us. So he's actually running 3 different agents all at the same time in the background that are going and gathering this information to create our files. Another reason why we want to do this stuff is to prevent what's called agentic drift. So if you just sat down and you told it to build this really complicated application, it might be able to one-shot it. Like Claude can one-shot some pretty cool stuff. Like it can make you a really interesting dashboard design. But what starts to happen is the longer the horizon or the more complex that your ask gets, as it cycles through those compaction events, it will kind of lose the thoughts of what it's doing. So it will eventually lose the plot and forget all the original requirements, and it'll start hallucinating new requirements. Or it might hallucinate whether it actually did a part of work or not. And what you'll end up with is an application that could be really disjointed. I've also seen instances where if you fail to do these planning steps, you might have 2 whole instances of the application written in the code, and all the code is duplicated, but written in slightly different ways. And it really kind of turns into a big mess that's hard for a human to go back and debug. So by forcing it to do these research processes for us, we're creating documents that it's going to carry with it all through its development cycles and through every compaction, and it will help us avoid those drift issues. It also speeds up the documentation generation. And this doesn't require any external dependencies, right? So Claude can do this right out of the box. And some of you may have heard of some other tools. There's a tool out there called SpecKit. Buttons has become really popular. There's another one called BMAD. And those are all like design specification template processes. And they use AI agents to do what we're doing right now, but they have a full templated process that they typically use. And you could substitute any of those tools if you wanted to do this differently, or if you wanted to use, one of the latest ones like Buttons to run a very large project. You could just supplement this part of the process with that. So it looks like he's finished doing the research, and it does look like it's running a little slow, and I apologize. They're having some API issues. But he's creating the research.md file now. And what we could do is we could go look at that. When he gets it done. All right. So here's all our research. We didn't have to do any of this. He did it all for us. Here's our asset inventory. He's identified things that are missing that need to be built before we get started. Documented all of the API processes and standards that we need to go through and use, and done some research on PDF libraries to decide what would be the best PDF tool for us. So now we need to do a little bit of brainstorming. Hey, Claude, read that research.md file. We're going to build something called the Policy Plain Language Converter. It takes dense policy text and produces an executive summary, a staff briefing, and a plain language public version. Here's some constraints. I want you to use a Node.js server and vanilla JavaScript front end. No databases, no authentication. Use the style guide folder for the UI, styling, and branding. We don't want to do any streaming output. This is a high functional MVP. Use your front end design skills to develop a clean UI UX template. Brainstorm the technical architecture, the Azure API prompt structure, and the potential edge cases. Write this to brainstorm.md. Let's keep it tight. All right, so we've just told Claude in plain language the concept that we would like to explore. And we're using it as a partner for our brainstorming by letting it tap into the research that it already did, and then take our constraints and our concept and then explore that and document that so we can have a conversation about it. One of the reasons that I told it to keep it tight is that some of these models have a tendency to get really verbose. They might try to design or suggest a lot of different stuff that you didn't even ask for. And sometimes that's called going off the rails. So by telling it to keep it tight and by giving it those constraints where we specifically told it what our constraints are, it will help keep it focused and directed and stop it from going off on a 30-minute tangent developing the new world's greatest thingamajig. I also told it some key constraints around keeping vanilla JavaScript and using a Node.js server. So instead of going out and building a complex React website or getting into some deep web technologies that may very well look really great, they get super complicated very quickly. And if you don't have experience with those frameworks or templates, they can be difficult to understand and debug. And it can also just take Claude a lot more time to code that stuff. So if you're just trying to build an MVP and you want to get something up and running to test the idea, it's a really good idea to provide those constraints. All right. So it looks like Claude has created a brainstorm for us, given us our architecture. He's given us our prompt strategy, some information about the UI UX, created a list of 25 different edge cases around like what happens when there's errors, how do we handle those error messages, how do we handle the output, how do we handle hallucinations and empty fields. So this is all stuff that if we hadn't specifically asked for it, we would find out very quickly after we ran it the first time that we did not remember to account for all these things. And while the AI can be pretty good at automatically finding some edge cases, if you don't specifically prompt for it, most of the time it will forget about them as well. And now it's got some open questions for us as well. So do we really want to do the PDF export? Do we want to show reading level metrics? Do we want a comparison view? And do we want sample policy preloads? So we can go open that file if we want. We could answer just right there, or we could just go take a look at the file. So here's all the work that he just did. We can go down to that open questions. So we'll want to answer these questions in our next prompt. And our next prompt is going to be all about creating the user stories. So now that we have defined this brainstorm and our edge cases, we want Claude to come up with our users. And we're going to tell Claude who our users are, but we want Claude to come up with all the stories and requirements around those users, but based off of this brainstorming. So we'll start off by answering Claude's questions, and then we'll give it a prompt for creating our user stories. Hey, Claude, I think we want to definitely have the download as a PDF button on our MVP. Word count would be a great idea, as well as the Flesch Kincaid score. And word count or token count is also important. I don't know that a side-by-side comparison view is necessary for the MVP, so let's skip that. I think we should preload at least one sample policy for a quick start button. I'd also like you to read the research and brainstorm markdown files and come up with some testable user stories and binary acceptance criteria for the following two personas. We have a public health analyst and a public health department director. You should cover inputting text, generating all three outputs, clipboard copying, and plain language error handling. We definitely want to include the PDF export services, and the acceptance criteria must be verifiable by a non-developer. Save this out to userstories.md and requirements.md. All right, so we have just defined done for Claude. We've answered his questions. And now we're letting the AI simulate these users and come up with our user stories and the full-on requirements document for us. So now with these, this will help the AI kind of build the standard for which the MVP will be based on. If you were building a production app, you might also want to split the user stories and acceptance criteria into separate documents, because each of those documents could get pretty long and they could be something that you want to have as independent documents. You may also want to verify those with your stakeholders. You could also have maybe had a meeting with your stakeholder previously, and you've already talked to them about what they think they want in an MVP. But I think it's still important, even if you go have those meetings and you have an idea of what you might want to create, you can take that file and put it in the repo. But I would tell Claude that, like, hey, Claude, I already have this information that I gathered from my stakeholders. I want you to read it and then refine it and add it into the process. Because I find that the AI just has a way of integrating things in the way that it likes to think, and it tends to perform a little bit better. And we're combining all these processes together in some places just to speed up and save a little bit of time. But we're still forcing the AI to define testable rules and define users and requirements, because again, all of these things are going to start stacking up to help it understand to build exactly what we want, nothing more, nothing less, and to stay on track. If you don't really know what you want, you can also just have a conversation with Claude. So we talked about this in the last session. It's totally okay to just riff and kind of brainstorm. So you could tell it that you don't really know what a department director for a large healthcare organization would be interested in? Can we talk about the features that they might find interesting? And Claude will be more than happy to iterate and get creative with you on stuff like that. All right. So our requirements and our user stories are already done. And I don't know about y'all, but if any of y'all do this stuff on a regular basis, you'll know that it's kind of painful sometimes to come up with all this stuff. But I think Claude just worked for what, 2 minutes and 34 seconds. And we've got this great requirements document. And look at this. We have our epics and our user stories. Everything's just already in a beautiful document. And note that he already put in the little check boxes. And as it goes through and creates these things, it's going to check these off too, right? So it will go through and make sure that it's created all these. And that's something that like one of our prompts can tie back to now, right? We can say in the future, you have to meet every one of these things. So make sure that you run the test and check that it does all of the things in the list, which is another way to make sure that you get what you want. All right, now we're going to move over and we're going to have it do phase 4, which is creating the PRD. Hey, Claude, thanks a lot. That's really great. So could you use all of the markdown files that we've just created and synthesize them into a single product requirements document that includes things like the project goals, the strict must-have features list, maybe also a list of out-of-scope constraints, things we don't want to build, and then include the technical stack specifications. This is now going to be our single source of truth. Let's keep it to 2 or 3 pages. I don't know if y'all have also kind of realized, but the talking and the speaking, and the more you do it and get used to interacting with Claude this way, the faster you can move. So if I was just sitting here having a conversation with Claude, I would get several thousand words out and into these iteration cycles and creativity cycles that it might take 10, 20, 30 minutes to do if I was trying to manually type this out into the web application. All right, so because we did all the research and the brainstorming and requirements gathering first, the output of the PRD is going to be much richer and more accurate than anything that we would get just from like a cold start prompt, right? Like if we tried to pack all this into one prompt and we didn't do those processes before, it would just kind of riff off some things and come up with an app, but it may not take into account like all these things. And so in 60 seconds, we now have our PRD. For our plain language converter. It looks great. It includes all those key things we talked about. The conversion, the readability metrics, a clipboard, PDF, error handling, branding. And he's made a strict list of all the out of scope items so we don't end up going off the rails and doing more than our MVP. And this is really important because if you don't tell Claude this kind of stuff, he will go and work for half an hour or 45 minutes, and 80% of the stuff might be cool, but it may be stuff that you'll never use. Okay, the next step is going to be breaking this down into sprints. And the reason that we want to break it down into sprints is again, it's to force it into a pattern of building the things that we know that we need, but we also wanted to break them down in dependencies so that it's not trying to build one part of the application and then realize that the technical infrastructure for that wasn't in place yet, and then have to go build that and get stuck in these loops where it can't finish development on one part because he has to go switch context into another part. Wow, Claude, that's a really great PRD. Could you take that PRD and break the work into exactly 3 sequential sprints? I'd like you to write them into a file called sprints.md. Don't include any timelines, but include specific files to create acceptance criteria for each sprint. Please make sure you don't add any features or sneak new stuff in. Now I've got some slash commands that work in the background that tell it whenever it creates sprint documentation to automatically take into account what's called a multi-agent workflow. So the prompt that kind of triggers in the background basically tells Claude to think about the dependencies, to always start your sprints with building the core dependencies first, and then working out towards edge dependencies and features, and to try to stack those things where we can use at least 3 parallel sub agents at the same time. So it takes into account what's called file ownership. And we can dive into that a little bit more in the next session. But essentially, we try to make sure that we don't stack up a couple of agents that might be editing the same file at the same time. Oh, already done. So another 60 seconds. We've got our sprint plan. So he specifically called out the files to create, all the acceptance criteria. So these are all of our testable acceptance criteria. If you're familiar with test-driven development, we're kind of getting close to that. And it looks like he's chosen to break this up into the server foundation and input UI, the readability metrics, clipboard, and sample policy. And then for the third sprint will be the PDF export and the polish. Pretty cool. So now we need to create what I call the mission brief. Some people call it the orchestrator file. The orchestrator file is going to be the file that tells Claude how we want him to develop and how we want him to follow the sprint plan. Thanks, Claude. That's a really great document. Could you please write the orchestrator.md file? This is going to govern your execution. I'd like you to include these rules in order. 1, always read the prd.md before you write code. 2, execute sprints in the order from sprints.md. 3, build only what is explicitly listed. 4, run the application locally and confirm that it starts without errors after each sprint. 5, verify that all acceptance criteria are met before moving on. 6, after a sprint passes, make sure you run your git add and git commit with a clear message. 7, never skip a commit. 8, run a final end-to-end test when you're finished. Use your MCP server to open the web browser and test it. Don't forget to provide that sample input. All right, you'll probably notice down here in my command line, there's this little bar that is kind of slowly filling up. That's our context limit counter. And I have a pretty conservative limit. So I set mine pretty low because I don't like Claude to get too far along in its context. Usually after about 150,000 tokens or so, you get into what they call no man's land, where tokens that start getting allocated in that area are subject to a lot of drift and become error prone. So I have my compaction events set to happen right around the 3/4 mark. But we've done a lot of work so far with Claude, and we haven't even come really close to filling up my conservative limit. So it looks like he's finished with the orchestrator file. Now it's time to let him work. All right, Claude, why don't you follow the orchestrator.md and execute all 3 sprints one after the other. All right. So this is the part that's going to take a little bit of time. I have some information that we can go over in PowerPoint. You're welcome to kind of watch for a minute. Does anybody have any questions so far about what we've covered? Has it been helpful?
Yes, for sure. Very, very good to see it happening live.
All right. Well, we could take a little quick intermission here if you guys want to take like 5 minutes. This process, typically when I've run it, it can take anywhere between 15 minutes and 30 plus minutes. So we could do a little intermission. You can get a refreshment and come back. We can go over a couple more slides and kind of watch the progress. It's also entirely possible that with the problems they've been having today, it may have some problems. So we could take a look at the existing project that I already created as well if you want to. But I'll give you guys 5 minutes and we'll see you back. And one of the things that can be fun to do as well is we can look at our project and we can see all the files that are starting to come in. So the package JSON is Claude has determined what libraries we're going to pull in to use for the project, and the package file lays out all the dependencies for the project. Started writing the style sheet and the JavaScript code. And we can see all that in real time. Writing all the code for talking to the endpoint. And one of the ways that this is a little different from, like, if you had a same interaction in like a chat GPT, or if you were like using Claude on the web through just the regular chat, is they're only capable of writing a couple of files in a single pass before they hit their context limits. And they're a little limited into what they can publish into that framework. So because Claude is working locally on this computer and it's using the harness, it's essentially capable of writing an infinite number of files. And because it can automatically compress those conversations, like you can see here, we're nearing this auto compaction event. When the memory starts to get full, he'll take a pause, summarize everything, and then pick right back up where he left off because he's made a to-do list. And we've provided it with all those requirements and all those documents. And it will carry over into the next session that it starts, all of those documents into the new conversation history. So the agents are getting really good at tracking where they currently are and what they still have left to do. I've been able to use similar methods to this and over about an hour, maybe come up with a pretty complicated project and then go to bed and wake up. And then he's got a 90,000 line of code application that needs very little debugging. And it worked overnight while I was asleep. So I wake up in the morning and I have my coffee and I take a look at this really cool application that Claude's created overnight. And that's, and like today is the worst it's going to get, right? It's only going to get better from here forward. And it looks like he's finished with sprint 1 and already moved on to sprint 2. And here you can see that a compaction event has been triggered. So I'm not 100% sure where the timing, as far as how long these take, comes from. Sometimes the compaction will take like 10 seconds and then zips right on to the next task. Sometimes it could take a couple of minutes. I don't know if that's due to how many files are in the history or what's going on, but it seems to be highly variable. So if your Claude gets stuck on this compacting for a couple of minutes, don't freak out. It's probably normal. But you can also see like Claude has worked for 35 minutes total before we got to that point where we're needing to compact a conversation. So the agents are getting extremely efficient with their token usage. So while that's happening, we could talk a little bit more about the process if you'd like. Does anybody have questions about any of the specific parts of the process? Would you like me to kind of just go through a recap?
Yes, a recap would be great.
Okay, great. So we talked a little bit about the context chain and the documents that we need to create, right? And what the process is for that. So the first thing that we do is we start off with orientating Claude and doing the research. And we're also kind of orientating ourselves. So we want to have a conversation to load the agent with current information about the type of the app that we're building. So we talked about, hey, go out and do this research about the OpenAI API. And we did that so that it would have the current information on how to structure the calls and the code. Because if we didn't do that, it might be recalling information from its training data that could be several years old. And that's just going to cause problems when we start going to build the app and make the whole process take longer and we have to debug it. It's basically just context engineering. So first step is context engineering to make sure that Claude has all current valid information. Other things that you might want to tell it about, right? So along with the API type information, just tell it about the domain, the target users, a little bit about your tech stack. So, you know, at your department, you might be on a different tech stack. Maybe you have Amazon Web Services or Google Vertex. That part doesn't really matter to the AI. It's very good at dealing with all those things. So the more information that you can provide about the project in the very first phase, the better it'll get. If you have real documentation, like if it's an internal project and you have some documentation about the project or the code that you're going to be working with, or like if you have some Power BI standards or data standards, being able to give it real documentation is awesome. And it's as simple as just taking a PDF and putting it in a folder that you're going to be working with. Talk about your constraints. It's really good to talk about constraints early on. And sometimes if you have a lot of them, even make it its own document, because the agent will factor those into everything that it builds. And if you don't give it constraints, oftentimes you'll find that it really wants to please you. And so it will go above and beyond and try to make a bunch of stuff that you didn't ask for because it's trying to intuit that you wanted those things. So by including the constraints, you also keep it on guardrails and keep it from taking, 2, 3, 4 hours of running off on its own and chasing its tail. Anytime you give it research or a complicated task, I oftentimes like to have it summarize what it learned as well. Brainstorming and defining. So this is where if you're not a developer by trade, like you can still do this stuff. You don't have to be a coder. You can just participate in plain language. You literally just talk about the features that you want in your app, describe the people that are going to be using it. Yeah, you have a question?
Yeah, it's just about the last phase. If you find like a hallucination or something that is wrong or not like completely right, do you just change on the file or you just like type back or say it back saying like, oh, this part is wrong, and how you usually would do that?
I would usually just talk to it unless there was a large change that we needed to make. If there was a big change, then I would go directly edit the document.
Mm.
And sometimes this doesn't happen very often, but I think it's important to kind of know that it can happen. If it does a really huge hallucination, you can get what's called context poisoning. Oh, here, I want to just pull this over. So Claude is using one of the MCP servers and is testing the application all by himself. So he's loading up the page. He's opened up my web browser. I didn't do this. And looking at the application. So see, he just pasted in that information. He's clicking on the buttons. Okay, so back to your question. If there's a really bad hallucination, then it will do what's called context poisoning or poisoning the well. And that whole conversation could get corrupted. So if that happens, and then like you find that maybe like 2 or more prompts in, it's continuing to gravitate towards that hallucination, you might have to start your conversation over. And there's a couple of ways to do that inside of Claude Code. You can type /clear, or you could just start a new session. It's not nearly as bad now as it used to be, but that can definitely happen. But I often,
Thanks.
yeah, for sure. But I often find that you can just literally have a conversation like you're chatting with somebody at work. Like, hey, Claude, I didn't ask for that. Can you delete that from the file, please, and only put what I asked? And that could be enough, right? And it'll go in and he can edit the file and pull that out for you. You'll kind of find your own specific way that you jive with the AI. And it's a little weird at first when you're just talking to it, but if you're not on a meeting presenting to a bunch of people and you can just be natural, it really does start to flow.
Yeah, I guess the models are way better now. I'm like thinking when if I was doing something before, like prototyping something and ask to change one thing, it would change other things as well. Like redo the whole thing just because I asked a specific point to be changed. So I was wondering if there's like a way to avoid that with Claude Code, or if it's like good enough that doesn't do that anymore. This is like months ago, so
I mean, it is so good now. It's crazy. Like, I mean, look, I haven't had to tell it to do any of this stuff. It just created the PDF engine and it downloaded the file automatically. It's going out here and testing like it's a real user. Now it's checking the mobile view. Like, we didn't ask for any of this, right? Like, it's just doing it. And they've gotten really good at understanding your intent and being extremely precise about following instructions. So yeah, like I had so many problems just like 3 months ago where you'd ask it to change one thing and then it would like totally wreck the whole file. And then you'd have to start all over or something like that. But they're pretty laser focused now and can go in and make really small edits to even like a large number of files and not corrupt them. All right. Well, that was a lot faster than I thought. Okay, so Claude says it's done. So in 18 minutes and 13 seconds, it's created an MVP app for us here. Looks like there might be a little bug with the button state, which we can talk to him about. It's got a little button for us to try the sample content. Looks like you missed the little spinner for showing us that it's processing. But we've got an executive summary that looks good. It's all within the right color guidelines. It's giving us a staff briefing version and a public version. We've got word count and reading level. It can download the PDF. Looks like we have a problem with our PDF. So what I would do is just give it that feedback. Hey, Claude, it's looking really great. It looks like whenever I click on or load my policy text, the convert policy spinner is stuck in the always on. And there's something wrong with the PDFs. Whenever I try to open the document, it shows that it's corrupted. Could you fix those things, please? So what do y'all think, though? I mean, is that pretty good for like the first round shot?
For sure, no. Wow.
So I think our actual, like our total time that we were actually working was probably less than 30 minutes because we did a lot of back and forth and talking in between our stages there. So if we were just sitting down and focused on building this app, within 30 minutes, we would have gone from the idea to having a fully baked requirements, user stories, sprint plan, acceptance criteria, and built the prototype MVP in 3 sprints that might have taken like a local dev team a couple of days at least to create for us. And we're able to do that all on our own just whenever we had the idea, we talked to the stakeholder that said they wanted us to try something out. So time from concept to demo was about 30 minutes. And now we can iterate too. So we've got, I mean, I would call this at least a semi-functional prototype. We're probably about 10 minutes away from having the bugs worked out. And now we can start adding features or changing the design, adding little accoutrements. One of the things that I like to do after I get the app dialed in and there's no errors that are happening with it is I like to tell Claude to go through multiple rounds of polish. And some words that I'll use are like, hey, Claude, what are some ways that we could delight the users of this application? Think about things that would be important to each of our personas as delights and make a list of them. I also always like to have it make a list or write everything out into a file and then execute on that file. You can tell it like, hey, just go fix this or add this feature and kind of get into a riff like that. But every time you do that and you leave it open-ended, you're inviting risk into the project. And there's a chance that it's going to do something you didn't ask it to do, either more or less, or for it to go off the rails. So if you have it think about the thing first and then plan the work. So envision the feature, talk about how you're going to build it, and then plan that work and then execute that work. It takes just a few more prompts in order to do that, but you'll almost always get a better product at the end. All right. He says that it's fixed. Yeah, there we go. So the PDFs now export. The little policy button isn't stuck running anymore. Anybody have an idea of a feature that they would want to add? We can have them add it real quick. Note takers? This is great, Claude. Could you come up with a list of 5 features or polish elements we could add that would delight the users?
It really wants the side-by-side comparison.
I think we should let them do it. What do you think?
Well,
Okay,
let the
Claude.
kid be happy.
I think let's go ahead and do the side-by-side comparison view. Could you go ahead and code that up for us? Make sure you plan the work first. While he's doing that, I'll pull over the version that I'm gonna give you guys in the demo as well. They're pretty close, even though we didn't show him the exact versions. So the masthead up here was very similar on the one on the left until I asked him to polish it up a little bit. But overall, it came up with similar design language. But you can see there's different nuances here, right? Like it chose to put the token count or character count. So in this one, it went by characters, and this one's using the tokens. This has more information that it displays after the analysis. And this is one of the things that's kind of interesting, right? So when you get this down, you might want to run one version just to kind of walk through your process. And then once you figure it out, you can now iterate because you can copy some of the core files and duplicate the folder. And then you can copy and paste your prompts and run the whole thing faster the next time and come up with another iteration, right? Because if you're paying for a Claude Code subscription, the cost to do these two, might be 50 cents or $1 in your total subscription cost. So you can very rapidly iterate on different designs or try out different colors and styles and move things around. And take the lessons that you learn from one version and iterate into another version. You can also just continue to iterate on a single version. Like if you didn't like the header or you want to add some graphics and stuff, you can keep iterating over and over. There's also some debate out there about whether you should continue to use the same session or not. I tend to, at least the way that I have my Claude Code set up, I'm comfortable running this. I've run them without resetting them for multiple days at a time. I clear my context out the way I have it set up, see how it's automatically gone into the planning mode and stuff like that. The AI today, like in the last 2 months, they're just so much better than they were that I feel safe keeping one session open for a very long time. But if you're having like those context problems, or you're finding that when you're asking for something, it's just not getting it, not figuring it out, you can type the / command /clear or /new, and it will create a new session. And that just clears the context, clears his memory of what's been worked on, and starts fresh. And when you start a new fresh cycle, Claude will go out and look at all the files and try to understand where the project is currently at. And in my experience, it can pick up just fine. But the way I have mine set up, and I told you about that memory system. So it kind of has this running list of all the things we've tried and what worked and what didn't work. So unless I'm just having like really horrible results, I tend to like to stay in one conversation. There is a feature inside of Claude that I want to show you. Use a new session. All right. There are flags that you can add on to Claude when you run it. Like if you want to use that YOLO mode we talked about earlier, you type out like dangerously skip permissions, and then it will stop asking you to do stuff. Another flag is called resume. So if you had to stop your work, close your computer, if your IT department surprises you with a system update in the middle of your project, you don't have to freak out because you can come in here and you can run Claude resume. And what that will do is it will show you the conversation history. So if you've had multiple sessions, it will show you all the different sessions. You can just come in here and pick the session that you want to continue with at the enter key, and it will pick up with that conversation right where you left off, like you never quit, which is really cool. All right. While he's making his little side by side thing, I'll finish up with our recap. So we talked about the brainstorming and the defining and why that's important, right? So even if you don't know how to code, you can still tell Claude what you want. And as you can see, we didn't have to actually provide any code at all to Claude. In fact, the way that we prompted, we just knew kind of a little bit about the agile process and told it to create the assets for us. We didn't have to create all those agile assets, and we got them all. Use plain language. Use stream of conscious. When you're talking, it's okay to just kind of freewheel it. You don't have to stop and think. One of the main powers behind the voice prompting is that you're not having to stop yourself and think about the typing. You can think more about the thing you want to build and just verbalize it. Remember, it's important to define what success looks like. And if you don't understand yourself what success looks like, just ask Claude to help you make those decisions. The clear success metrics will really help Claude stay on track. And on your first shot, like we showed, get you something that's like 99% done. If you're not sure about the features, again, just let the AI suggest the features and then, like ask for 10 or even 20 ideas and then pick the 5 you think are really cool. Sometimes the AI is going to come up with stuff that you never thought of. But that scope discipline is really critical, especially if you're talking about building the MVP and then iterating on it. If you tell it to build like all 20 things all at once, you start reducing the chances that your first output is going to be functional. You also increase the probability that it's going to go off the rails and build things you didn't ask for, or just generally wind up with spaghetti code, which we don't want. The user stories, again, are like super important. So after you do the brainstorm, make sure you have the AI synthesize the user stories. That's the foundational context to make sure that it steers and it creates the things that'll delight your users. Make sure that you get both the requirements as well as the acceptance criteria. Acceptance criteria can be a pain to create if you're doing them by hand, but just remember, you can just tell Claude for every requirement, make sure you have acceptance criteria and let him do the heavy lifting. It's also important to boil everything down into a single PRD because the PRD is the most important document that it's going to carry forward in all of the rest of the conversations. And the PRD is going to reference all the other documents. So that allows you to just tell Claude to follow the PRD and you're automatically going to get the context for the rest of the project. And then make sure you take the PRD and you have it do sprint planning. So this is a way to make it do a more complex planning cycle that breaks the work down into manageable chunks that you can remember, have him git commit at the end of each work package so that in case you need to roll back in your project and go back in time, you have a really good working spot that you can roll back to. And then finally, when you have all that done, you wrap it up with the orchestrator document, which tells the main Claude that's going to use all his agents how you want him to manage and run the project. And that document is the key to having it run for 30 minutes or an hour or 2 hours without needing any of your input. So this deck is included in the repo link that we sent earlier. And here's also a little recovery card for things that, you know, could go wrong when you're working with Claude. And there's some real quick little things that you can do to recover if you run into those. And so what we just did was we went from a brainstorm idea and we just chatted with Claude and we came up with a full project across 3 sprints that would have taken a small team a couple of days or even a week or more to create. And we got all the documentation and all the artifacts that our project manager or a scrum master would have asked us for. We can communicate to our IT department. You know, if this thing works and we really want to deliver this, you have the whole package that you can hand over to your IT department that lets them build it for real. And none of that required a single line of typed code. We didn't have to write anything in VS or any other code editor. You didn't have to learn how to write JavaScript or HTML. So hopefully that was helpful. And in the next session that we do, we're going to cover multi-agent orchestration, and we're going to build a meeting transcription app, I think, if it's going to work out. And we'll show you how you use multi-agents all at the same time, running in multiple different windows to create an app in a much larger scale and even faster. And I thank everybody for their time. Let's take a look and see. Okay, he says he got his side-by-side comparison in. Are we ready for the reveal? He really wanted this. So there it is. We have our original policy text and then the version that's all cleaned up and pretty. Ready for our users. Look at that. Yay, Claude. That's all that I have for you. You have the package online. If you have any trouble with it, and any of those that are watching this later, if you need some help getting it running, or if you want to do experiments and play with Claude and you have questions about it, feel free to shoot me an email or give me a contact. You can also just ping me on GitHub. I'll be happy to help out however I can.